done multiplexer and adder circuit on virtual lab, but you have to perform the practicals on the kit. So let's see your second experiment how you can perform on the kit. Okay, so please see the theory regarding this. Already you studied this part in the theory lectures. So experiment number 2 is study of demultiplexer decoder. So for that you have to use the IC 74138. So let's see the pin diagram for the 138. So it is a 16 pin IC. Pin number 8 is the ground. Pin number 16 is the VCC. Now there are the three inputs. This is A, B and C. So IC 74138 act as a 3:8 decoder. Okay. So now here your ABC, out of ABC, C is your MSB. Now there are the 8 output pins. So let's see Y0 bar, Y1 bar, Y2 bar, Y3 bar, Y4 bar, Y5 bar, Y6 bar and Y7 bar. Okay. So these are the input output pins and the supply pins. Now to activate the decoder we require the 3 enable pins. So pin number 4, 5, 6, there are the 3 enable pins. Out of that your 4 and 5 are E1 bar and E2 bar. So these 2 pins are active low. Okay, and pin number 6 is the E3. So this pin is active high. Okay, so this is your pin diagram for the 7438. Now by using this 74138, you have to design full adder circuit, then you have to design full subtractor, and also you have to design binary to gray code converter. Okay, so let's see how you can build the circuit for the full adder by using this decoder IC. Now for a full adder, already you know this full adder. Okay, so these are 3 inputs and 2 outputs. So C is your MSB as per your pin diagram. So that's why here I have taken as C is your MSB bit here. C, B and A. So next is there are the 2 outputs, sum and the carry. So as per your theory part, you have to first complete your full adder circuit. So as you know, when there is single 1 is there, your sum is 1. When there are 2 1s, there is sum is 0 and carry is 1. And only for the last case, there are the 3 1s, so you will get the sum is 1 and the carry is 1. So from this truth table, what you have to do? First you have to find out the sum mean terms. So you have to check the sum column here. So sum is summation of mean term 1, 2, 4, 7. So where you are getting 1s, only that mean terms you have to mark it here. So this is 1, 2, 4 and 7. Same procedure you have to apply for the carry. So for the carry you are getting summation M 3, 5, 6 and 7. Okay, so now here as per your mean terms you can write your equation as y1, y2, y4 and y7. Okay, so let's check again your pin diagram. So as per your pin diagram for the 74138, your outputs are active low, bar is there. Okay, so that's why directly you cannot implement this expression by using the OR gate. Okay, so that's why you have to apply the De Morgan's law. So for the De Morgan's law, if you put a double bar here, your meaning of the expression will remain as it is. Okay, so after this double bar, you have to separate this lower bar. So that time already you know this rule, okay, of this law. So when you separate this lower bar, your sign will get changed. Okay, so it will change from addition to multiplication. So that's why your final expression you are getting as y1 bar, y2 bar, dot y4 bar, dot y7 bar and whole bar. So now your expression is in terms of complement of your output, that is in terms of bar. Okay, so already your y1, y2, y4 bars are available here, okay, which are active low outputs, and your overall there is a 1 more bar, means here instead of AND gate you have to go with the NAND gate. Okay, so same rule you have to apply for the carry. Now for the carry again there is you are getting the final term as y3 bar, y5 bar, y6 bar, y7 bar and the whole bar. Okay, so now you are getting the 2 expressions, one is for sum and one is for the carry. Now let's see how you can implement this for the by using your 74138. So your IC is 74138. Okay, now let's see, as per your truth table you have to apply your C, B, A. These are the 3 inputs, so that 3 pins you have to connect to the your input section. Okay, now to enable that IC you require the 3 enable pins. So as per your pin diagram, pin number 4 and 5, these 2 are the E1 bar and E2 bar, so that 2 pins you have to connect to the the ground, and then pin number 6, that is E3, it is active high pin, so you have to connect to the VCC. Okay, then you have to connect the supply pin, that is your 8 and the 16 to the ground and the VCC. Okay, so now again we have to check your sum equation. Now let's check which output terms we have to make activate. This is Y1, Y2, Y4 and Y7. So here only that pin Y1, Y2, Y4 and the Y7 will go to your first NAND gate. Now this NAND gate we have to use a 4 input NAND gate and the IC number is 7420. Okay, and that output, this output of the NAND, you have to connect to the output section, so you will get the sum term. Same, you have to check the equation for the carry. Now for the carry, Y3, Y5, Y6 and Y7, that piece you have to connect to your second NAND gate, and output of that NAND you have to connect to the output section on the gate, so it will give you the carry. Okay, so after the connection, you have to apply the inputs. Okay, you have to change your input as per your truth table. So this all combinations you have to make it here, and as per your truth table you have to verify your sum and carry. Okay, so hope students you understood this procedure for the full adder. Now by using the same IC you have to design full subtractor as well as the binary to gray code converter. So same procedure here you have to follow. First you have to write down truth table for the full subtractor. So from the full subtractor, again you will get the two outputs. One is your difference and one is your borrow. So from that difference and borrow, you have to find out the mean terms. You have to convert it into a specific form of equation, that is in terms of bar. Okay. So once you get these two equations, your input section, your enable, your supply pin will remains as it is. Only there is a change for input of your NAND gate. So as per your equation, you have to make change in the input of the NAND gate. Okay, and only change here two outputs you have to consider as this is difference and the borrow. Okay, so this is the procedure for the full subtractor. Same you have to verify your truth table of full subtractor. Next is your binary to gray code converter. So in the binary to gray code converter, again it is a 3-bit binary to gray code converter. So first you have to prepare the truth table for the 3-bit binary to gray code converter. Again from the G0, G1, G2 column, you have to find out the mean terms and then you have to write down the specific equation in terms of bar. Okay, and again same procedure you have to follow it. Only your inputs will be changed for the NAND gate. And now here are the 3 terms, G0, G1, G2, 3 outputs you require. So that's why 3 NAND gates you require. Okay, and as per this equations you have to make connection. Then at the output you are getting G0, G1, G2, and then you have to apply your binary code and you have to verify your grade. So hope students you understood this procedure for the full adder, full subtractor and the binary to gray code converter. Thank you.